exercises that you posted on LeetCode or no?
LeetCode?
Like practice
No, they're not on LeetCode.
Okay, but to find practice exercises, would it be a good idea to go on LeetCode?
I don't think there are LeetCode exercises that are appropriate for this stage of ESC180.
Okay, so not yet.
No. Alright, hi everyone. Hello. So today, quiet down please, hello. So several exciting things happening today. We'll continue repeated computation, and we've already done for loops. So we'll talk now about while loops. Then we'll talk a little bit more about range. And then we'll basically do some problem solving and talk about how really while loops are equivalent to for loops with range, if you know what to do. And there's going to be an exciting surprise in the middle of the lecture. I'm not sure what that's about, but we can figure it out probably. Okay, all right. And I should say, the surprise, if it happens to be a quiz, is not going to be about the Monday lecture, because like the recording got messed up. So it's going to be about other stuff. Okay, all right. So last time what we had, so I'll just quickly redo what we've done because I think it's worth doing, is some of you, about half of you, practiced this in the lab as well. So the basic idea is you can go through different possibilities. So in this case, try every possible divisor of n, and if none of the potential divisors, divide n, then n is prime. And the way we did it is we said for I in range, and then we said n minus 2, and then we tried every possible divisor I, so we said if n mod I is equal to 0, then we said okay, that's not prime, and then if we never returned prime, at the end we said return true. And here this was I plus 2. So this way, if you remember, I plus 2 went from 2 and up to n minus 1. That's what we wanted, is try every possible divisor between 2 and n minus 1. If n happens to be 2, then we never get to trying to divide by 2, so that works out. You could say that in the beginning we'll just check if n is small or equal to 1, and if it is, then it's definitely not prime, so we'll just return false. So that way we get rid of the weird cases where 0 and 1 don't really have 0 is divisible by anything, arguably. 1 is not divisible by anything except 1. Anyway, they're not considered prime. And then everything else is just handled by this loop. Okay, so two things that we're doing here. So one is this very simple mechanism of making I be 0, then 1, then 2, and so on, up to n minus 2, not including n minus 2. That's what the for loop does. And then we had the abstract idea of if you need to check every possible divisor, well, you can do it with a for loop. All right? So, and that's basically kind of, at least kind of for now, that's what for loops do, is I is 0, 1, 2, and so on. Of course, this I doesn't have to be I, it could be anything, right? So it could be something like this, and as long as you're consistent, I'll undo it, don't copy it. But as long as you're consistent, and you can make it consistent using copy-paste, that's all fine. So, okay. So that's one way of doing repeated computation. Here's another way of doing repeated computation. So, and that's while loops. So the basic template is you're saying while, and then you have a condition, and then you have the block. And this means keep repeating block while condition is true, right? So what you're doing is you're checking, is the condition true? If it is, do the block. Is the condition true? If it is, do the block, and so on. So here's an example. I'll set I to be equal to 0, and then I'll set n to be equal to 5, and I'll say while I is smaller than n, print I, and increment I by 1. So increment just means add on to. And if you remember, that's the same as just saying I is equal to I plus 1. So if I run it, what happens is I print 0, 1, 2, 3, 4. So why is that? Well, because initially I is equal to 0, and we're saying keep repeating this block, so keep repeating print I, increment I by 1, while I is smaller than 5. So initially I is equal to 0, that's smaller than 5, so we do this block. We print 0 and we make I become 1. And now I is 1, so we check, is 1 smaller than 5? Yes, it is, so we print this again. And again, I gets incremented by 1. Eventually I becomes 5, so when I is 5, it is not true that I is smaller than n, because I is 5 and n is 5, they're equal, so you're done. All right? So this, of course, we could do with a for loop as well, and arguably it would be better to do it with a for loop. So in general, in this kind of situation, if you know how many times the loop, so this is referred to as a loop because it kind of goes round, will repeat, use for in range, right? So this you could do with a for loop as well. On the other hand, some situations you don't know ahead of time how many times you want the loop to repeat. That is when a while loop could be useful. So here's an example. So to remind you, so log 10 of n is, how many people know? Okay, so some people. So this is the logarithm. So this is answering the question, to what degree do I need to raise 10 so that I get n? Right? So in more mathy terms, 10 to the k is equal to n. What is k? Right? So that's the question that we're trying to answer. So just kind of to get us going, so what's log 10 of 100? Anyone? Yes.
2.
It is 2, yes, because 10 squared is 100, yes. And then what's log 10 of 1 million? Yes. It is 6, yes. So it is 6 because 1 million is 1 with 6 zeros after it. This is 7. So 1 with 6 zeros. To what degree do I need to raise 10 in order to get 1 with 6 zeros, well, 6. Right. So, okay. So I'll write 1 million is this much. So, okay. So that's the question that we want to answer. And of course, there is a built-in function in Python, but let's say that we want to implement our own. So how might you do it? You have a number, let's say 10,000, and you want to know to what degree do I need to raise 10 in order to get 10,000. So you could do it the really silly way, the way we've done it in the lab, if you did the lab, or the way we did primality testing. Like, is the answer 0? Is the answer 1? Is the answer 2? Is the answer 3? And so on. Well, eventually you'll get it, but that might be kind of slow. Another way to do it is to say, okay, log 10 of 10,000, let's say, is the number of times that I can divide 10,000 by 10 before I get to 1, right? Because you start with 10,000, you divide it by 10. What do you get? Well, you get 1,000. 1,000 you divide by 10, you get 100. So every time you divide by 10, you take away a 0, right? And eventually you get to a 1. So here, basically, so here it's like 1, 2, 3, 4, which is correct. So you need to divide 4 times before you get to 1. So how can we figure out how many times do we need to divide 10,000 by 10 in order to get to 1? Well, you got to do it, but you don't know ahead of time how many times you got to repeat the computation. That's the whole question, is how many times should the loop run before you get to 1? So that's exactly a question that's answerable with log. So let's do that. So we're saying, okay, so the answer initially, I'll set it to 0. And now I'll say, okay, so while n is greater than 1, divide n by 10. So divide you can do in the same way that you do plus. You can do divide equals. So that's the same as n is equal to n divide by 10. So here I'm doing integer division, and that's because I want it to be the case that if n is really large, I can still compute the log if n is an integer. All right? And here I'll say answer plus equals 1. Right? So what am I doing here? So I said, okay, answer is going to be, as it happens, my eventual answer, but also it's the number of times that the loop runs. So every time I run this block, answer becomes larger by 1. How many times does this run? Well, as many times as I need in order to make n become 1. And then I return answer. So we'll get back to this because now we move on to the interesting part of the lecture. Oh my God. No, my mic is on though. Oh, in the lecture hall. 1? Well, I mean, I think it's pretty long. Yes, indeed. So quiz like right now. So you knew that was coming. So the grading is gonna be best 3 out of 4. One of the questions I promise you is really easy. So let's go. No talking. Hey, no talking, please. Go on Quercus, answer. You have until 4:30. Well, you need to finish by 4:32, so 2 more minutes. Yeah. So I'm giving you until 4:32, so 2 more minutes, please. Alright, finish up, please. Alright, so given the amount of talking, well, it might be that people will get something wrong, but we'll see. Okay, what are people thinking? Okay. Can people hear me on YouTube? I mean, as far as I can tell, everything is working, but... Okay, so someone's quiz ended before submission, so I'm giving one more minute. I'm giving you one more minute to finish up if you want. And given the amount of talking, everyone who submits will get full credit. Next time we'll bring in TAs to police you guys, I guess. I know. So I'm giving you until 4:35 to submit. Okay, so people can submit still until 4:35. Everyone who submits will get full credit this time. Next time I'm bringing the police. I'm sure, Siddhartha, I'm sure people will listen to you. Can't open the quiz. If so, Cecilia, maybe email me. We'll do it offline. So all right. So I kind of knew this quiz would be probably difficult, except of course people can just if you're quick at typing, I guess you can type this into the computer. That's not disallowed. But I also kind of wanted to point out that no one came to office hours yesterday and asked me about this stuff. I assume it's not because this quiz is super easy. You need to know this. The midterm is the quiz. Okay, I'll give everyone full credit this time because people were talking anyway. But the midterm is going to be for real, and it's going to have questions like this. So got to know it. Are you taking this quiz? The correct answer is A. What is the output of the following? So what's going on here? So here we have x equals 4. That's a variable that's outside of any function. So this x is global. Then we're doing f of x. So f of x, if it returns something, you could use its value if you wanted to. That's not happening here. We're not saying answer is equal to f of x or anything like that, right? We're just saying f of x. So the only ways in which f of x could change things is if f of x changes a global variable, so it has a job, it has an effect, or it prints something. In this case, it does neither, right? So it does neither because it's saying x equals 2, but this x is a local x. Unless you say global x, it's not global. So this x equals 2 modifies the local variable x, and then it returns 3. Well, you never do anything with this 3. So this is analogous to the situation where you have something like something potentially meaningful, right? So you could have square of x, and you say return x squared. If in the main block you say square of 5, well, that doesn't do anything. It doesn't print anything, right? So if you wanted to, you could say a is equal to square of 5, and then you could say print a. That would print it. Or you can print square of x, but saying square of 5 by itself does nothing, right? So maybe to emphasize this point, if you say square of 6 here, well, a is still 25 because you said a is square of 5, and then you said square of 6. You never stored it anywhere. All right? So what this suggests is that f of x doesn't have an effect, doesn't change a global variable. When you say print x, what it does is prints the global variable x, which is 4. What about here? So this is one of the two situations where you have a syntax error that we saw, right? So if you have a parameter named x, and you also say, oh, x is global, that's a contradiction. We only had two situations where this kind of thing has arisen. This is one of them. So syntax error means nothing gets printed, you just get a syntax error. What about this one? Well, it's actually the same as Q2. So the only change here is I changed this to a y. That doesn't matter because H, just like F, returns 3. We don't use this 3. Doesn't change any global variables. So saying x equals 2 without saying that x is global means that you're setting the local x to 2, not the global one. So you print x, well, that means that you print 4 again. All right? So this stuff, I would say this is kind of one of the more difficult aspects of ESC180 traditionally. Like it's difficult, right? It's genuinely difficult. But I think one of the reasons that it's difficult is people don't just kind of write down whatever we had in lecture, just write down the rules. There aren't many of them, about 4 or 5. Just write them down when you're applying the rules to a new situation. Just kind of think, okay, like which of the rules apply? Is it one of the situations where there is a syntax error? I know when there are syntax errors. And then, for this kind of thing, when I say x is equal to 2, is it global, is it local? Well, there is a rule. It's only global if it said global x. So it must be local. Right? So if you kind of do it step by step, like it's a computer, it follows rules. You can follow rules just the same as a computer as long as you just know to follow them. One, I think, mistake is to try to just impressionistically kind of like glance at it and kind of eyeball, okay, I think I know the answer. Well, no, you probably don't. I kind of specifically asked those questions in a way that like a simple intuition just won't do. You need to actually apply the rules. So to repeat the rules, they're like not difficult. So a variable is local unless you are accessing a variable's value and there is no local variable by that name. The variable is specifically declared as global in the function. Anything else, the variable is local. So local variables are only accessible from inside the function in which they exist. Parameters are local. If there is ambiguity about whether the variable is global or local, it's a syntax error. And this arises in two situations that we saw. A parameter is declared as global, or one parameter. or something like a variable is declared as global but is accessed as if it's local. Sorry. Not declared as local, but is accessed as if it's global. That is it. So just look at any situation, look at which rules apply. That should tell you what's going on. All right. So I'm sorry that, so I realized that I've kind of interrupted the flow of the lecture for the quiz. I think that's like the only way to do it, because in the beginning, like not everyone has come in, and then at the end everyone's tired, so you kind of got to do it in the middle. I hope it's still useful. I recognize that the quiz is kind of probably stressful, so for that reason, well, I kind of knew that I was going to say that everyone gets full credit for this one. But I also wanted kind of, because the midterm is kind of far away, so I did want to indicate to people that, like, if you see that something in lecture is difficult, well, I mean, maybe all of you have known how to answer, but based on my experience, that's not true. So, like, more people should have been more worried about this material from last week. Okay. And kind of the goal of the quizzes, right, is that, like, you're in lecture, you're not just, oh, like, it's going to be on the midterm, we'll worry about it later. The goal is that, like, you hear something where you feel you're not fully grasping it, either you kind of get help or you'll study on your own or whatever, but you don't, like, leave it for later. That's not going to work very well. So, okay, all right. Back to the material for the next quiz. So to remind you, what we were doing before is we were saying, okay, so we have an input n, and then we try to divide it repeatedly by 10 until it becomes until it becomes 1, and then we stop, and we want to know how many times we divided the number by 10. Right. So the way we set it up is we said, okay, so n initially is whatever, 10,000, and then while n is greater than 1, it's like English, right? So while n is greater than 1, we keep repeating this. And what we're doing is divided by 10, add 1 to x. All right? So let's trace it. So I'll give it 10,000. We'll put the breakpoint here. So we are here. So ans is, let me check what Discord is saying. You can press any, okay, why not? Okay, so ans we can keep track of here, so right now it's 0, and n we can keep track of here, right now it's 10,000. So we're saying, okay, is n greater than 1? Yes. So divided by 10,000, so this 10,000 is about to become 1,000, and add 1 to ans. So one iteration, an iteration is one execution of the block. So one iteration from the Latin ita for walk, I guess. So like it's like one, I guess one step would be kind of the translation from Latin for iteration. So one iteration, so ans becomes 1 and n becomes smaller by a factor of 10. And then another iteration, ans is 2, and n becomes 100. All once more and becomes 10. So we take away 0, add 1 to n's, and we keep going while n is greater than 1. So now n has become 1, so one last time we increment a, and now we're here and we skipped the block because n was equal to 1, so now we're just returning n's, so we're returning 4. So n's is basically the number of iterations that the loop ran, the number of times that the loop ran, which is the number of times that we needed to divide the number by 10 in order to get 1. So that would now make it so that a is 4, which is correct. So here, of course, we're assuming that the input is an integer. If the input is not an integer, it's going to do something, not very interesting what. It's going to keep going until n is not greater than 1. You can do something that will give you a fractional answer as well. That would be more difficult. So, okay. So that's one application of the log. So you'll note that it wasn't like a super easy thing, right? So you had to think about the problem as well. That's in the nature of the while loop, right? So if the situation is such that you don't know ahead of time how many iterations you need, well, that kind of indicates that the problem is not completely trivial. If you know how many iterations you need, you want to use a for loop anyway. Yes?
If you were to put the answer on the variable outside of the function, would that work just still probably wrong?
You couldn't really, right? So return needs to be inside the function. You can't access answer. It's a local variable. You cannot access it outside the function. So it has to be where it is. Right. Okay. So okay, all right. So that's like that. So let's go back now to kind of more trivial applications of while, just to get more of a sense for what it does. So in order to do that, they need to quickly tell you a little bit more about range. So what we had with range so far was just for I in range n. So in fact, you can specify not just range n, you can say where you want to start, so it doesn't have to start with 0. And you can say where you want to end, and you can say what the steps are that you want to take. So you can say kind of start, and then end, and then step. And you can specify what the start and the end are. So you can say, for example, start is 9, and you can say end is like 1, 2, 3, 4, and then you can say step is 20, for example. And I could input those directly, it's just that I wanted names, and what's going to happen is I starts with 9, and then rather than going in steps of 1, it goes in steps of 20 here, and it goes up to but not including 1, 2, 3, 4. So this is where the up to but not including gets to be a really useful formulation, because kind of before it was kind of weird, like for I in range n, like up to but not including n, like why don't you just say n minus 1? Well, the reason is that it really is up to but not including n. So here we go, for example, up to 1, 2, 2, 9, and then the next time would be over 1, 2, 3, 4, so that's why it's not included. In some special situations, it happens that you would be at exactly 1, 2, 3, 4. If you go to the next step, the rule is up to but not including, right? So I goes from start up to but not including end in steps step. Right? So sometimes, like quite rarely, you have situations where you want to go down rather than up, and you can do that. So you could say start is 1, 2, 3, 4, and you can say end is equal to 9. And then in order to get from 1, 2, 3, 4 to 9, you need to do negative steps rather than positive steps. So you could say, for example, step is minus 20. And that would be like that. So you start at 1, 2, 3, 4, and now you go, oh, we printed this stuff as well. So you go from 1, 2, 3, 4 in steps of minus 20 now, and you go down to, but not including, in this case, 9. Right? So if I said here 14, for example, so 14 would not be included. The last thing that would be printed is 34 because I'm saying down to, but not including 14. So that's like that. So that's kind of like that, and that suggests a way to fix our prime so that it looks a little bit nicer. So here I did like for I in range n minus 2, and really what I could have done is I could have said, well, I want to start with 2 and I want to go up to but not including n, and now I can just do n mod I, so that's arguably nicer. So here, implicitly, if I don't specify the step, it's 1, so this would be the same. You don't need to specify if the step is 1. Right? So here, now that we have steps, you might say, okay, all right, like, why are we doing like 2 and 4 and 6 and 8 and so on? If the number is not even, there's no point in trying to divide it by 8. And you might try to, like, there's more efficiency gains to be made here, but you can try and say, okay, I'll try to divide it by 2 the once, and then I'll do steps of 2. Right? So I'll say, if n is equal to 2, return true. And then if n mod 2 is equal to 0, return false. Because if it was 2, I already said it's prime. If it's not 2 but it's even, then it's not prime. And now I get to go from 3 and up to n, but now in steps of 2, so that would be more efficient. I'm trying fewer numbers, because here I'm just trying to divide by the odd numbers. In fact, do I need to go up to n minus 1? Anyone? Is there like a smaller number that I can go up to? Yeah. Half an n is good. You can actually go down more. Yes, exactly. So square root n is right, and that's because if n is divisible by d, then so n divided by d is equal to d2 or something, and that means n is also divisible by d2. And one of d and d2 is small or equal than square root of n. Because if they're both greater than square root of n, then the product would be greater than n. Right? So that suggests that if n is divisible by anything, then n has a factor that's smaller than square root of n, or equal. Yeah. Well, so no, so this is correct. So, oh, you mean this? Yeah. So, and yeah, thank you. Yeah. Make sense? So that kind of suggests that here, instead of saying n, I could say square root of n. So I could say n 0.5. So here I do need to account for the possibility that the factor is actually square root of n. So for example, 9 is 3 squared, and you need to include 3. So I can do something like round plus 1 just to make sure that I'm not missing the last number. And that's a very common thing in programming, where you want to make sure that like you actually check the last thing and don't miss out on it. So here the way I made sure of it is I just said, okay, like go up to plus 1, not including plus 1. That would include the square root of n if it's a whole number. Yeah. Well, so a while loop is useful if you don't know how many iterations you have ahead of time. If you do, then a for loop makes more sense, and that's just because the housekeeping around making the while loop work is kind of annoying, right? So you can, for example, forget something like this, and this would result in an infinite loop, which we'll discuss on Friday. All right, I think that's a good place to end. We'll do more while loops on Friday. See ya. Thanks. Bye. I think I deserve more applause for the full credit for the quiz, but okay. For
the one you just showed. Big circle, basically. Thank you.
So it's also on YouTube. Well, probably.
On the last, hopefully.
Yeah. Sorry, I can't hear.
Can I talk to you regarding lab?
Okay. Yeah.
Actually, my checking was done, but I can't see my grade on it.
Okay. It sometimes takes some time.
Because lab 1 has been created.
Yeah. So it sometimes takes some time for the TAs to enter it. Sometimes it happens that the TAs just make a mistake. So if it's not in by the end of the week, you can email me and I'll check with the team. Yeah.
I'm Cecilia,
Okay.
and I didn't submit the answers, but I
Okay.
didn't know that it's possible.
Okay.
And I didn't know like the reason for it.
Okay. What?
Like the reason for the answers. For the
Oh, okay.
questions.
I mean, that's good. You like I didn't submit a goal for you?
Yeah, I only like the first question is yes, and then I didn't click on the
I see.
answers.
I think that's probably fine. Just to be sure, just email me with your name and your user ID.
Okay, thank you so much.
Yeah.
What does that essentially mean? Like the wrong sheet. So it starts at P and then ends at
Around square root of n. Sorry, what do you mean? So to the power of 0.5 is square root, right? So it goes up to the square root of n.
Oh. And that's one. And you said
In steps of 2. Yeah, so it's so you start like try to divide by 3, then 5, then 7, and so on. Hi. So I can call the that person for you.
She already checked like where she was sitting and stuff.
Yeah. So sometimes people give it to the lost if it's like in the lost and found. Hey. Hello. Hey. So I'm in my hole 150. There's a student here who's looking for a laptop that was left here an hour ago. Do you know anything about it? Okay. Yeah, I mean, in my whole 150, there is a person who is around, right? Or is it you? So in my whole 150, there is a tech person who is around, isn't there? Yeah, I mean, but like they might know. Do you know where they are, or like can they come over? I think they hung up on me. That's right. That's right. I was just wanting to ask the tech person who's around my whole 150 if they knew anything about it. So I was wondering if I could get in touch with them.
Sorry, I can come and talk to you.
Thank you. Yeah, so often in my experience, like students give me laptops a lot of the time, just not in this case. So maybe they gave it to the previous person, so it might make sense to connect with them.
Yeah, I was
And
gonna do that.